Okay, yes. So in the previous class, we were looking at the coordinate system. So to project any model or anything onto the screen, it has to be defined with respect to the coordinates. So it makes it easier for the programmer as well as for the computer to understand, and the uh, to be displayed it onto the screen also. So thereby this coordinate system is very much important. So when it comes to coordinate system, it can be divided into three parts in three varieties. Okay, so one of them is the world coordinate system. The second one is the model coordinate system, and the third one is the viewing coordinate system. Okay, so there are three varieties in the coordinate system, that we have the world coordinate system, model coordinate system, and a viewing coordinate system. So this world coordinate system is nothing but it is an infinite space where all the other thing, the model coordinate system and viewing coordinate system, should fit. So it is just like it is something like we are in this universe which has got an infinite dimension in all directions, right? So just similar to that is this world coordinate system. So anything that has to be there, okay, that has to be represented onto the display screen, okay, it is there within the world coordinate system only, which is actually an infinite space, just to understand it in simple. Then comes the model coordinate system. The model coordinate system is nothing but if we take up a CAD model and we are going to do a part modeling. So in this part modeling, we will be selecting one particular plane, whether it's the XZ plane or YZ plane, and you selecting that particular plane, we will start sketching the 2D drawing, and then come out of it after sketching and convert it into 3D drawing by extrusion or revolved protrusion or cutout, anything like that. So that three planes, that what we are able to basically see in the solid modeling packages is nothing but the the model coordinate systems. So we'll be able to see something like this uh, in the CAD softwares, right? So this will be for the side view, this will be for the horizontal plane, and here we'll have one more for the front view. So we'll have these three planes that will be coming up into picture. So we'll select any one of the plane and then we'll start sketching. So it will show this one as XZ plane, This one will be X and Y plane. This will be YZ plane, right? That is nothing but the horizontal plane, vertical plane, and side view plane for side views, right? Which we know for the basics of drawing. So that same thing is nothing but the model coordinate system. Viewing coordinate system is to understand in simple is that, so whatever is being drawn using this model coordinate system has to be displayed onto the screen. So it has to be adjusted to the screen size. So there comes this viewing coordinate system. So when we take a look at all these three, how are they actually going to look about is that it is here. So these three coordinate systems. So this is the viewing screen that we have. Okay. And the world coordinate system is an infinite coordinate system, nothing but like our universe. We don't know where the exact origin and all those things are there. So it's something like that. And then comes the model coordinate system, where the model coordinate system is nothing but our x-axis, y-axis, and z-axis that we generally use to draw, right? And the same thing is also been depicted in SolidWorks and in other modeling softwares also as working coordinate system, WCS, right? So that is nothing but the model coordinate system also. Even in our ANSYS or Abacus also, we will use one option called, especially in ANSYS, we will use the word called to enter the coordinates. We'll go to an option called in active CS, that is in active coordinate system, nothing but the model coordinate system, which where we'll define what is the x value, y value, and z values, right? And whatever that we are going to enter. So you say, for example, when we take up CAD modeling and we are going to draw one a rectangular cube like this as shown in this diagram, and say for example the dimensions of this are about for say 1000 mm by 1000 mm and 1000 mm if it's a cube. So but for 1000 mm it may not fit onto a screen and the size is actually too big. So if that has to be fitted, then it has to be adjusted, scaled down properly so that it has been proportionately reduced, and including the axis, including the XYZ axis, it has to be proportionately reduced and it has to be displayed onto the screen. So to convert this big diagram into which has to be displayed onto the screen in where it has to fit exactly, then we need to convert this model coordinate system into viewing coordinate system, and that is how it is going to be displayed onto the screen. So the viewing coordinate system is nothing but the system that is the coordinates to represent the diagrams, where it takes care of that, where it is going to fit onto the screen or the display monitor, right? So this is the relation between the world coordinate system, model coordinate system, and viewing coordinate system. So let us start with the model coordinate system. In the model coordinate system, we will be able to give only the x, y, and z coordinates only. That is, all the dimensions, all the data that we give should be only in Cartesian coordinates. Even though in certain cases where we give revolved protrusion, where we want to make it into cylinder and all those things, we enter one input data to convert a circle into a cylinder, or half of this portion of a cylinder to be converted into revolved protrusion. So there we'll give an input called 360 degrees. Though it is polar in nature, it will be converted into Cartesian coordinate only. So this model coordinate system can understand only in Cartesian coordinates, where it should have an x, y, z values. If at all, if it is not there, so what are the inputs that has been given, it is going to convert everything into x, y, z coordinates and store that data. And that is how the data will be stored. So what is the reference points in terms of x, y, and z coordinates? That is what will be stored. So that becomes easier to retrieve the data also. So once when we start, say for example, we have drawn one diagram, and then we are going in for, okay, we are going to save the file, close that file. And after some time, we are going to open that same file. So now it has to retrieve the data from the hard disk, and it has to project the same drawing in the same manner once again. So thereby it is going to retrieve the data by capturing what is the XYZ values, convert it into displayable form, and we get back that display once again onto the screen, right? So that is the model coordinate system. So and the next thing is the viewing coordinate system. Is that in the viewing coordinate system, there are two things that we have generally. One is whether we wanted to have it in two-dimensional form or in three-dimensional form. That is the first thing. The second thing is that how should it be projected? There are two types of projections that is coming place, which is nothing but the concept taken up from the engineering drawing itself. So one of the projection methods is the orthographic projections, and the other one is the perspective projections. Okay, so it has to follow either any one of them. So depending upon what is the inputs and how it has to be displayed, so it is going to suitably adjust or convert the data into orthographic projection or into perspective projection. So The next thing is that now coming to the type of projections, what is happening in this projection? How is it actually displayed onto the screen? So as I mentioned, there are two varieties. One is the orthographic projection, the other one is the uh, perspective projection. So in this orthographic projection, as we know, so here what we see, this rectangle is nothing but our screen, and it we what is going to actually happen behind the screen, the rays of light is being projected. Okay, so if we are going to take up, this is the model where we are able to see a kind of rectangular cube. So it has got its front side as a rectangle of this length and width. So only this portion has to be projected over here. So in this case, what we want is only the front view. Okay, and what we need over here, yes, it is able to fit onto the screen easily for the given dimensions, let us assume for the time being. So what is going to happen is that here we have the world coordinate system, that is YV, XV and ZV over here. So it is something like an imagination where the model is present behind the screen, and from there onwards it is being projected. So to understand it in simple, it is like this. Uh, so when we go to a movie theater, we have the screen, projection screen in front of us, a large screen, but the beam of light onto the screen which has been projected, that is the projector, is actually present behind us, behind the viewer sitting into the theater. So it's a very small box and a small projector through which it is going to be projected. Okay, so it is something like that. So it is behind the screen, there's a kind of projection on which this image has been projected onto the screen. So for every point over here, it will be projected parallel to this, that is perpendicular to the screen of projection itself. The rays of light will follow the projection lines. So we'll be able to get the same shape and size without any change in its dimension or diminishing in its shape. There is no scaling down of the shape at all in this type of method. That is the orthographic projection. When we come to uh, the perspective projection, so in the perspective projection, what is there? So one is the view site, that is the origin of the world coordinate system from where the object is to be present. The other one is the viewpoint. It's an imaginary point onto the display screen. It's an imaginary point. So from where it is going to deviate towards the object. So as we see, the dotted lines is going to start diverting from a point of origin, that is the center of projection, towards the corners of the object. But in between the center of projection and the object, there is the display screen that is coming into picture. So even though if the size of this object is actually big, as I mentioned, if we have to draw one rectangle by 1000 mm by 1000 mm, so it doesn't fit onto the screen actually in actual dimensions. But still we have to get it onto the screen in a so that it is going to fit exactly onto the screen in a suitable manner. So in that case, what will happen? This perspective projection is being taken up. So it is going to diminish all the points equally and get a same shape but of a smaller size which can fit onto the screen. So that is the perspective projection. So perspective projection, one more example is that we have seen uh, in uh, in the drawings. I'll just show that drawing in just a moment. Yes. we have seen some drawings like this, okay, where we are standing, the observer is standing and looking for a very long distance. So what we'll be able to see is that if we have a railway track, the distance between these two tracks gradually decreases and merges at one point. Similarly, if we see the boundary of this is also going to merge at the same point. And this, if we have any other mountainous region or anything like that, and even that is also going to merge at one single point. We have trees over here, and all that is going to be diminishing as it goes away from the observer. So this is a perspective drawing actually. This is a perspective drawing. So it's just like this. Even we have seen aircrafts flying in the space. So when it is actually flying, we are able to see it is of a miniature size, but in actual, it is not the size of the aircraft. When it lands onto the ground, it's a very huge aircraft, right? So when it goes far away from our sight, it is uh, it is of diminished in nature. The size has been reduced in all directions simultaneously. So this is a perspective projection where the lines are drawing from the single point. This is the center of projection. So this is the center of projection from where everything is being drawn to the viewpoint. So the viewpoint is nothing but where the observer is standing. That is the person who's drawing this diagram. But the center of projection is very far away from here, right? So this is a perspective projection. Yes. So coming back to this, so the view site is the place where the actually compared to the diagram is where the object is nearer, and the viewpoint is actually where we are standing. That is this seeing it from the display end, seeing the display on the monitor. So it has to be diminished and it has to merge at the center of projection. So this is the perspective projection where all these lines will have to coincide at this viewpoint, and in between this object and to this viewpoint we have this display screen. So it is going where it is going to intersect onto these screens, that is, so this particular corner is going to be projected over here, and similarly we have this particular corner to be projected over here, right? So what is going to happen is that it is the size has been considerably reduced. So every point is going to be reduced to the same extent. So ultimately we get a diminished image, okay, which is nothing but the perspective drawing. So where do we actually use this? Uh, is that for just for simple understanding, one is when we use uh, when you draw the 2D diagram, and if it is say for example if the dimensions of this rectangle is only for 10 mm and the height is only for 5 mm, definitely it will fit onto the screen. There is no doubt about it, right? It will definitely fit onto the screen. But if the same length is for about 1000 mm by 500 mm, so it doesn't fit onto the screen. So once when we give fit, it is going to reduce these dimensions and give it up so that it is going to fit accordingly, and so that all the other objects surrounding this is also going to be equally spaced onto the screen. So that time it is going to change automatically into perspective view. Okay, so this we will be generally seeing in one is in zoom in and zoom out. So I want to just only zoom this particular portion and look at it carefully. So that time all the other regions will be outside the screen, outside the screen. But definitely it is not outside the coordinate system. That is the model coordinate. No, it is not outside the model coordinate system, but it is only out of the viewing screen. That is the viewing coordinate system. We are only focusing onto the viewing screen. We want only this particular portion of the rectangle to be seen in an enlarged manner. So there is the difference between the model coordinate system and viewing coordinate system. So what we want onto the screen is to be adjusted. So whenever we use zoom in, zoom out option, it is going to use this it is going to convert this model coordinate system. Whatever the portion of the model that we have chosen, only that particular portion will be put onto the screen and adjusted onto the viewing coordinates. Whatever is the size of the screen, it will match to fit equally in that screen space. Yes, so this is all about the perspective projection and the orthographic projection that we have. So the next thing is, yes, so the next thing is that we have seen uh, over here in the perspective projection. In perspective projection, this is the actual size of the model, but it is going to be diminished when it is going to appear onto the screen, right? So there is a considerable reduction over here, which by how much should it reduce is the next question. So there needs to be a calculation for this, by how much it has to be reduced once it has to be displayed onto the screen using perspective projection. So for this, uh, the calculation has to be done in the background by the system. So how does it actually calculate is what has been represented over here. So if we take up this model over here, one is the, say for example, what they have taken in this case. Okay, one is the side view and one is the top view. That is the top portion of this rectangle and the side portion of this rectangle, not the front view. So once when you look at this, if you take uh, this as the y-axis, this as the z-axis, and this one as the x-axis. So for the top view, it requires the x and z axis, because this shadow, when we look from top, will fall onto this particular plane. Once when you look from the side view, it is going to fall onto the YZ plane, right? So both of these things, if we have to convert it into perspective projection, that is, we have to reduce the size. Okay. So taking one corner of this rectangle, which is actually of this particular size shown over here, if we take one of the views, okay, the side view is what they have mentioned over here, so it actually falls onto the YZ plane. Okay, so here what we have, if we take up one of the top left corner looking from the side view, let's just reduce this size. Okay, so we are going to take up only this particular rectangle and this particular point. So if that has to be projected onto the screen, it has to be diminished, right? So what is the distance? So viewing point is an imaginary point, as I said already, depending upon what should be the zoom in and zoom out. So that will be arbitrarily placed by the system, and which is actually at a distance of s from the screen. Okay, which, because this viewpoint uh, is an imaginary point. Okay, so how is this actually? So just for our simple understanding, whenever we use any CAD packages, uh, we are going to keep the mouse pointer anywhere onto the screen, and we are going to scroll the mouse button, right? We are going to rotate, we are going to use the scroll button, okay? And we are going to roll out so that we can see that the image, the model size decreases or enlarges. So how is that going to take place? So if I keep it up exactly at the center of the screen, what is going to happen when I'm going to say, for example, I'm going to zoom it out. I want to make the image to be in a bigger size. So I'm going to zoom it out, or so I want to enlarge that space. So all that rectangle is going to enlarge in a much larger space. But if I'm going to keep the mouse pointer somewhere at the lowermost corner of the screen, then what is going to happen is that the it is going to diminish with respect to this as the center point. That is the viewpoint. Keeping this, I'm going to reduce this. I'm going to reduce the triangle, keeping this as the viewpoint. Okay, so what will happen is that it will diminish in shape. Okay, but it will move on, it will no more further be onto the center of the screen. It will slowly start moving. If we have the rectangle to be center of the screen, it will slowly start moving towards the point where we started to scroll. That is the center of projection or the viewpoint. So it will start as we change the scaling, it will start moving towards that point. So it is very similar to that. So the viewing point is an imaginary point, and it is at a distance of s based upon from where we click. Okay, and the object is generally projected overall distance from the viewpoint after the screen and up to the end of the object in that particular view. That is from viewpoint to the screen and then up to this particular end. So starting from here to here is our distance L. Okay, and this object is for a size of say for example some distance, for a distance of, let us assume, ZV as they have indicated in the diagram over here, which is for this distance is only for ZV, right? So here, how now if I see this is the actual shape, this point has to be drawn, I mean projected onto the screen using perspective projection. So it has to be diminished. So it has to come up to here. So by how much it has to reduce, and what is the coordinate of this ys in the y direction? How much should it be reduced is the question. So to come up with this, uh, we are going to use uh, the to find the uh, similarity rules between the triangles. So there are two triangles over here. If we carefully observe, the one of the triangle is starting from the viewpoint from here, going up to this point, that is onto the object, and coming up onto the axis, the z axis, which makes one triangle. Yeah, which makes up one triangle. So we have this viewpoint, one point of the triangle, YV second point of the triangle, and this coordinate onto the axis. Now the next one, the other triangle is inside this itself, starting from viewpoint up to the screen and onto this rectangle, sorry, the axis and over here. So we have something like this. So if I name this as the viewpoint V, okay, and this is the screen. So there is one point on the screen intersecting. There is another point of this rectangle which has to be diminished. So if I know these things, I can find out to how much it has to be reduced over here. What is this value? We can find out, which is nothing but the ys value and the xs value. So ys value is for the side view, xs value we get it from the top view. So considering the same thing, so this top half is for the side view, the bottom half is for calculating for the top view. Okay, and to get the perspective projections, right? So if we have to find out what is this ys value, we have this rule of triangles which we have done in the high school. We have studied one derivation. So using that itself, we are going to use. So what does this say? The ys value. We want to find out how much should be this value. That is, what should be the coordinate or which particular pixel should be highlighted to represent this point onto the screen. So this is the screen value. So how to get that is the s, nothing but the distance from the viewpoint to the screen divided by the overall length from the viewpoint to the end of the object minus the zv value, because this is the zv value, the length of the object in the side view. This is zv. right? So minus this. So overall length minus this value, I will get yv itself, okay, into the yv value, that is the height. That is the height. At what height it is placed onto the y-axis. This will give where is it ending, where, what is this. So this has, say for example, x coordinate and y coordinate. This x coordinate value is given by this L minus ZV. This y value is given by the height. What is the height on this onto the y-axis? So by these two into the yv value, if we do, we will know how much it has to be reduced and which particular coordinate onto the screen it has to fall. So that particular pixel will be highlighted, will be energized. Okay, so similarly, this is what happens for every point onto the object is that has been created. So similarly, if we take up the top view also, it is the same case. So once again, it is, so xs value, if we have to find out, it is going to be the s value, that is the distance from the viewpoint to the screen, divided by the overall length minus whatever is the length of this object in top view. In top view. Right, so thereby it will give me the x and y value for this xv. So this x value is nothing but L minus zv comma the y value, that is this, sorry, the xv value, nothing but what is the distance from here to here to represent this point. So what is this value is nothing but the xv value. So thereby what we need, so if we know this, then we can get this point by how much it has to reduce onto the screen. So this is how it, this calculation, this algorithm is going to run, this calculation is going to be done, and that is how we are going to project everything onto the screen. So whenever we do zoom out, zoom in, and all these things fit to the screen, so this is going to continuously run in the background, and that's how we get the display. So we will see sometimes that if the system is overloaded, we won't get the display immediately as we change. Sometimes the system will hang. That is because it has been overloaded, because it has to do all these calculations for every point, right? And then suitably arrange all these points, then get it projected onto the screen. So that is the so much of data is going to run behind to get the answers, and that has to be projected onto the screen, right? So this is all about how it is going to be done using perspective projections, and how much it is going to be reduced, how it is going to be calculated is done by using this way. Okay, so yes, okay, we'll take up this the remaining in the next class.